Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so we are now in topic 7, as you see in the screen here now, with the topic of permutation and combination. So this topic is something we call very close in our daily life. Okay, so sometimes we need to make some selection, or we choose something and then we need to make some arrangement. So we look at that both of this term, where permutation in Bahasa Malaysia we mention as an pilih. Okay, I'm sorry then. Pilih atau. So from the root word of pilih and atau. And for combination means that we select we call the numbers of object from a group of the objects then, okay, and then we don't need to think about the arrangement. We just select. For example, if I have letters of A, B, C, D, E, okay, 5 of them, I need to choose 3 out of the letters from A to E, and the arrangement is not important then. So it's either we select, for example, if from A, B, C, D, E, I choose A, B, C, then the arrangement of A, B, C, A, C, B, B, A, C, and all that is not important. Okay, we consider that as a 1. So then let's take a look at the first part of this lecture for 7.1, permutation. Okay. Use the techniques of counting, find the number of permutation of n different objects, and find the number of permutation of r object from n different object. Okay, which I think that I'm not going to explain all this. You may read by yourself, and we're going to look into the example, so that makes all of you clearly with all this definition. Okay, consider a padlock which has a code to unlock it. I think that this object is familiar with all of us and important. Even you have it in your hostel. Okay, you use it to lock your locker or maybe your door. So if we set the code, to unlock this padlock as 4-digit number 757351, then 3517 will not work to unlock it. Why? Because here the order of number is important. So then this is permutation where the order of element is very important. Okay, so then permutation is an ordered arrangement of all or part of a set object. Example, for A given A, B, C. So how many arrangement of letters A, B, C are there? Okay, using 3 diagram, from A, letters of A, B, and C. So we may begin the arrangement begin from the letters of A. Then the second letter, it might be B or C. If I choose A first and then B, then of course we have another one here with a C. Or A, then C. Okay, A, C, then the final letter will be B. So then outcomes is A, B, C, and A, C, B. Look at this. We begin with the letter of A. Then next, if we begin with the letter of B, then second letter is either A or C. So if we look at the arrangement, then if B and then A, then the final letter will be C. Or otherwise, if B and then second letter is A, okay, then this is end up with the CA, BCA. So same thing goes to this one here now. So there are 6 arrangement of letters. The order look at this one here. The order is important. So multiplication counting principle then here. Okay. How many arrangement of letters A, B, and C are there? Okay, so then we got letter of A, B, and C. Then let's say we got 3 places here. Okay, so there are 3 choices or 3 selection or 3 ways of solving this. So if I choose one of it, means that I choose the first one out of 3 selection here. So come up with 3. Let's say if I choose the first letter here is B. So for second place, there are 2 selection here, 2 choices, A and C. So if I choose one out of 2 choices, 2 here, let's see if I choose C, then lastly finally here, there's only 1 letter left with 1 place here, A1. So that equal to 6. How many ways there can be form a number code for this padlock? So every single colors here, okay, if I imagine that there is a places for every numbers, because we got we call the selection of numbers here, call numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The selection of numbers here. And for this, let's say repetition are allowed. Okay. It did not mention here that repetition are not allowed. So in general, we assume that repetition is allowed. Then from a 0 up to 9, there are 10 of them. So we got first places. Let's take a look at the red one, the red color here, button here. And then second here is for green. The next is blue. And the last one here is with yellow. So they have 4 places for, we can form a code for this padlock. So then the first places, how many choices do we have? How many ways? 10. So it is 10. Okay. Repetition are allowed. So if I choose the first number here is 5. May I choose 5 again in second selection? Yes. So repetition are allowed. So 5 are also choices that we have. So then there are still 10 selection and another 10 and finally another 10. It is 10 to the power of 4. Okay. So the first place, any numbers from 0 until 9, there are 10 selection of numbers. So if I choose 5 out of 10 here, so there are 10 selection. So then if I choose 5 again or any numbers, there are 10 selection because there are 10 numbers here. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, repeat again and again. So come up with 10 to the power of 4 equal to 10,000 ways. Okay. All the numbers can be repeated. Sorry, it appears after that. Okay, so then types of permutation. If I have, let's say, I get the letters of A, B, C, D, and E. So the number of permutation and different objects taken n at a time, meaning I have 5 letters A, B, C, D, and E, and I choose 5 of them and I arrange in a different ways. So we come up with NPN. And then this one here, the numbers of permutation of n different taken are. So just imagine that I have letters of A, B, C, D, and E. Okay, out of these 5, we call letters of A until E, I need to choose any 3 of them. It's either A, B, C, A, C, D, A, D, E, B, C, D, B, D, E. It's all up to you as long as we choose 3 out of 5. So then, for this one, we come up with a term of NPR. And numbers of permutation, where some objects are identical. Identical means that, let's say, if I have the word of, say, equal mathematic. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. All letters are 9 here. But then there are letters that repeated. Okay, M, M. So M repeated twice. A, and also A. A repeated twice. T, and also T repeated twice. So E, I, K repeated once only, appeared once only. So then this, and this that we call represent that we call objects are identical. It means that repeated a few times, okay, more than once. Okay, the term of factorial, which I think that you have learned, look at this before. Okay, I'm not going to repeat that. Okay, x factorial. Okay, for n Pn equal to n factorial. Okay, the numbers of n object, and then we select all of them and we arrange, so it come up with n Pn or n factorial. In how many different ways can be letters of word learn be arranged? Okay, so it means that here there are 5 of them. 1, 2, 3, 4, 5, and we take them all and we find out how many ways can be letter of L-E-A-R-N be arranged. Okay, just imagine that if I roughly guessing what is the arrangement that be possible for this. Okay, L-E-A-N-R, L-E-N-A-R, L-E-N-R-A, L-A-N-E-R, and so on. Okay, we need to list down many times, okay, because there are many possibilities here. So just imagine that it is 5P5. Out of 5 letters of L-E-A-R-N, we're going to choose 5 of them, all of them, and we arrange, so it is 5 factorial. So it is 5 times 4 times 3 times 2 times 1 equal to 120. 5 times 4 equal to 20, 20 times 3 equal to 60, 60 times 2 equal to 120. Okay, so there are 120 ways of arranging these all letters of L-E-A-R-N. And look at this, all the letters appears once only. Okay. In how many ways the letters of learn can be arranged if first letter and the last letters are vowel? Okay, class, vowel is an A-E-I-O-U. And look at this one here now, we have one E and one A. Okay, so there are 2 possibilities here. Okay, first 1, 2, 3, 4, 5. There are 2 cases here. With case number 1, okay, if we begin this arrangement with letter of A and end up with E, because the first and the last letters are vowels, A and E. So when A and E were arranged in the first and the last here, so we got L, R, N to be arranged here. So 1 ways of arranging and also 1, because it's only 1 A and 1 E. So straightly we put it here and here. So L, R, N, there are 3 ways of arrangement. We call the letters of L, R, N. And then case number 2. Again, if we begin with E and end up with 8. Again, we have LRN that we need to arrange here. So 1 times 1. And then LRN, LNR, RLN, whatever. So come up with 3 factorial. So 3 factorial equal to 6 and another 6 here. So the number of ways of arrangement equal to 6 plus 6, that is equal to 12. Okay. So now, for NPR means that from the numbers of letters or numbers or persons, we take only a few of them. Okay, so it is NPR. Example, there are 6 competitors in the final of 100-meter race. So just imagine that in a race of 100 meter, okay, so there are 6 lanes. There are 6 lanes. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. And there are 6 competitors here. 1, 2, 3, 4, 5, and 6. And this is the end of the race, okay, for 100 meter. So the first 3 competitors who complete the course will all receive medal. In this case, they did not mention about the first place, second, and the third winners for the gold medal, silver, and bronze. They just want to get the best 3 out of these 6. So 6B3. Okay, calculate number of different possible group of medals here. So then it is 6B3 equal to 6 factorial divided by 6 minus 3 factorial. Okay, as you see, 4 in here, n factorial divided by n minus r factorial. Okay, equal to 6 factorial divided by 6 minus 3, 3 factorial. Actually, you can just get the answers from the calculator. I just make the count manually. 6 times 4, 5 times 4 times 3 factorial divided by 3 factorial. So 6 times 5 equal to 30. 30 times 4 equal to 120. Okay. Okay, now, some objects are identical. So, they consider the number of permutation of letters in the word of A and N. So, 2 N's we consider as N1 and N2. And the number of permutation of this is 3 factorial. It can be arranged in order of this one here. Okay, so we switch the position of N1 and N2. So from A, N1, N, N2, then we get A, N2, N1. But here, we consider this as a 1 because N is the still letter of N. Nothing different. It's different from the situation if we talk about 2 persons. 2 persons, human are different even though both are women, for example. Women number 1 and women number 2. Even both are women, but they are different. Okay, but for letters of N, we consider that as a 1. Okay. So then, okay, there are 3 different ways of arrangement. So it is equal to 3 factorial divided by repeating of 2 N's here, 2 factorial equal to 3. There you go. Okay. Example 6. How many different multiplication can be made using the letters of mathematics? Okay. First of all, we counted the letters one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the number of letters here is 11. Then we look into the letters that repeated, okay, where M appeared twice, 1 and 2. Then A, 1 and 2, okay, and T, 1, 2. Okay, so repeated of M, A, and T, all repeated twice. So then the number of permutation equal to 11 factorial divided by 2 factorial, another 2 factorial, and 2 factorial. Okay, so use a calculator then here, and you get 4,989,600. Okay, you may use a calculator for this one here. Okay, conditional permutation. Example 7. A group of cadets consists of 4 males, and 3 females are seated in a row. How many ways can be done? If there is no restriction. Okay, you can read all the questions then. Okay, right now I list down again. There are 4 men and 3 women. All persons here. Okay, now the arrangement without restriction, meaning that there is no rules that we say that it must begin with the men first, or begin with the women first, or is a men and women, men and women. So in the first case here, the arrangement, we call the arrangement is free. Okay, so we consider this one A as a 7 factorial. Okay, equal to 5040. Question B. All female cadets are to sit together. So how many members are here? 4 plus 3 equal to 7. 1, 2, 3, 4, 5, 6, 7. Okay. When 3 women must sit next to each other, just imagine that if we imagine that these 3 places for women, we consider as one unit. Okay. And then for men, so 1, 2, 3, 4, 5. Okay, so let's say if I move this, imagine that the unit of 3 women here is still considered as one unit. So 1, 2, 3, 4, 5. So with this one here, we assume that there are 5 units. 1, 2, 3, 4, 5. 5 factorial. By the way, among those 3 women, they also can switch the position among them. Okay, there are 3 women here, but these 3 women are 3 different persons. Okay, and they may also change the position among them, among them. So we consider it also 3 factorial. Okay, so 5 factorial times 3 factorial equal to 720. And C. All female cadets must be separated. Okay, class, just imagine that, let's say, all 4 men here. Okay, the first place for men, second, third, and the fourth. Okay, 4 places for men. 1, 2, 3, 4. Okay, and those 3 women are not allowed to sit next to each other, not even 3 or 2. Meaning these 3 women must be separated. So just imagine that there is still a space. Okay, just imagine that this space is a chair. Okay, a chair. So I arrange the chairs for the guys. 1, 2, 3, 4. And the chairs for the girls, I arrange later. It can be here, 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 and here. So if I arrange the chairs for the girls, it can be this here place and here and here. Okay. All these three girls with the red chairs separated among them. Or here and also here. Okay, so there are 5 spaces to arrange the chairs for the girls. Any of this, and so then we come up with the calculation. We call the result of 1, 2, 3, 4 factorial times width. There are 5 spaces for the girls. 1, 2, 3, 4, 5, and we only need to arrange 3 seats for them, 3 spaces for them. So it is 5B3. And use a calculator, it gives you 1,440 different arrangement. Then D, the male and female cadets sit at alternate places. Alternate places, because we got 4 men and 3 women, so just imagine that we arrange 7 seats. 1, 2, 3, 4, 5, 6, 7. And according to the numbers here, 4 men and 3 women. Okay, so we strict that it must begin with a man and end up with a man too. Alternate places means that it's a man, women, man, women, man, women, and that. Okay, so then among these men, they may also change the position among themselves. So 1, 2, 3, 4. 4 factorial. And for women, there are 3 of them. Okay, and these 3 women may also change the seat among them. So we get 3 factorial. Then it is equal to 144. Okay. Okay, this is a solution for C just now and D. Okay, or I already answered it in the earliest slides. At all alternate places, men, women, men, women, men, women, men. Okay. And then we got a letters digit of 2, 3, 5, 6, 7, 9, and we're gonna form 3-digit numbers which is less than 400 and all that. Okay, so again, the numbers of 2, 3, 5, 6, 7, and 9. So the first question here, we're gonna form 3-digit number of x which is less than 400. So in this case, the first place, it must begin either begin with 2 or 3. 200, okay? 200 something, which is less than 400. Or 300 something, which also less than 400. Not 5, 6, 7, or 9. Okay, so the first one here now, case number 1. Okay, 2, 3, 5, 6, 7, and 9. Case number 1. If we begin with 2, there are only one ways of selection because there are only one of digit number 2 here. Okay, so then less than 400. How many ways that we can choose here? 1, 2, 3, 4, 5. So 5 ways, and then 4 equal to 20. Case number 2, if I begin the arrangement of numbers, I select number 3. Okay, so there are only 1 3 here, so there are 1 ways of solution here. And then how many digits left in here? 1, 2, 3, 4, 5. So 5 different ways of selection of this. So if 5 And let's say we choose 9. Then how many left then next? 1, 2, 3, 4. So there are 20 different ways. So case number 1 plus case number 2, then 20 plus 20 equal to 40. Okay. Then next, question B, 2, 3, 5, 6, 7, and 9. Okay, 3-digit numbers, let's say X, which is an odd numbers. Okay, 3-digit numbers, that this is an odd numbers. Odd numbers meaning the last final place here end up with either 3, 5, 7, and 9. For example, 269 or 327. Look at this one here. 9 and 7 is an example of odd numbers. 269 is an odd numbers. 327 is an odd numbers. Meaning, if we divide 269 with 2, it's not going to give you a round figure, but it gives you a numbers with a decimal place here. Okay. So now, with the odd numbers, we got 3, 5, 7, 9. If we choose one of it, it is 1 out of 4 selection here. So there are 4 ways of this. If I choose, let's say 7, so then the rest of the first and second place are free to any of these 5. 1, 2, 3, 4, 5. So 5 times 4. Okay, 5 times 4 times 4 equal to 20 times 4 equal to 80. And then, for question C, the record arrangement of 3-digit numbers, which is less than X, which is less than 400, and it is an odd numbers. Okay, so there are 2 cases here. For case number 1, for example, 1, 2, 3, X less than 400, because we got 2, 3, 5, 6, 7, and 9. If we begin with numbers of 2 here, so there are 1 ways of arrangement of selection of this, 1 only. Okay, because it's X less than 400, it cannot be 5, 6, 7, or 9. Begin with 5, 6, 7, 9. No. Okay, so if we begin with 2, and it is an odd numbers. So how many odd numbers here left? 1, 2, 3, 4. So 4 ways of it. If I choose 5 here, let's say 5, for example. So how many numbers left here now for second place here? 1, 2, 3, 4. Okay. So then 1 times 4 times 4 equal to 60. Case 2. 1, 2, 3. Okay. 2, 3, 5, 6, 7, 9. If I begin the first numbers here with 3. So there are 1 ways of solution, because there's only 1 number 3 here. Then it's an odd numbers, meaning it end up with odd numbers. How many selection? How many choice we have? 1, 2, 3. Okay, 3 have been taken in the first place. So there are 3. We call odd numbers 5, 7, and 9. So there are 3 different ways of arrangement here. So if I choose 9 here, if I choose 9, you may choose 7 or 3 or 5. It's all up to you then. So how many numbers left for second place here? 1, 2, 3, 4. And it is equal to 12. So the total numbers of ways equal to 16 plus 12 equal to 28. Okay. Okay, exercise For this, I let all of you to try the question and try to solve the question by yourself. Okay, for question A, the number of arrangements start with the A and end up with the finish with M. There are 19,958,400 ways of arrangement, and all letters I are together. This one is 119,750,400 ways of arrangement. Okay, so that's all for today. I do hope that this videos help you to continue with your tutorials. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.